Today we're going to talk about warehouse automation, specifically the future of warehouse automation. In this presentation, I'm going to lay out several key myths of warehouse automation that have caused many companies to spend more money than they can afford buying machines designed for a peak that they'll never see, with an ROI they'll never attain because their business changes faster than their fixed automation can change. I'm going to explain how warehouse automation has, for too long, been focused more on speed than efficiency, and how intelligent software, technology-empowered people, and flexible machines are the key to getting the focus back on efficiency. Firstly, my name is Seth Patin. I'm the CEO and founder of Accelogix and LogistiVIEW. My companies are dedicated to designing and building integrated, software-based warehouse automation solutions for our customers. I started my career at Red Prairie just under 20 years ago, and I've spent my entire career working with warehouse management software. During that time, I came to the realization that traditional warehouse management systems focus mostly on optimizing data rather than people. I started LogistiVIEW in 2014 to build a different kind of warehouse software that focused first on connecting people and optimizing processes. Over the last several years, LogistiVIEW has built a software platform that connects the entire digital workforce, humans, robots, and artificial intelligence, to drive new levels of automation in efficiency in the warehouse. To understand why software is the future of automation, we should start by addressing some traditional beliefs that I'll call myths about warehouse automation. Firstly, I often hear terms that make it sound like speed is the same thing as efficiency. Process improvement automatically increases throughput. A highly engineered fixed path maximizes throughput. Machines are always faster than people. And wave-based processing controls throughput and prevents bottlenecks. Now, why are all of these myths? I'm calling them myths because they are, in many ways, common understandings in the industry today, but understandings that many have already begun to see as antiquated. And so systematically, I'm going to go through each one of these myths and explain how software is the solution to rethinking automation and rethinking the truth that is associated with many of these myths. So first, we're going to start with speed. Automation needs to be designed for efficiency, not just for top speed. Many large automation systems are designed for the proverbial church on Easter Sunday, but how often are they actually used to capacity? As an example, let's talk about the Chevy Impala streetcar versus the Chevy Impala NASCAR. The NASCAR version costs 10 times as much to both own and operate, but only offers a 30% improvement in top speed. The streetcar can easily do 80 miles per hour, and it can push to well over 100 miles per hour with just a bit more gas. You only need the race car if you plan to spend every second you possibly can above 150 miles per hour. The NASCAR version of the Chevy Impala does 0 to 60 in under 3 seconds. The streetcar does it in 7 seconds. Now, if your warehouse moved at the same speed, and all that time and acceleration and braking were less important, how fast would you actually need to go? Said a better way, are your people or your automation equipment being fully utilized? One of the major reasons automation systems are over-designed is because they're targeted for a top speed that's necessary because utilization is not constant. But efficiency is ultimately maximized not by getting up to speed as fast as possible, but by staying at the same speed as long as possible without slowing down. The key to making that possible is intelligent software to create a flow or a smooth flow of work automatically. So let's discuss the next myth. So singular, we tend to think of warehouse automation in terms of a sprint. The faster you go, the better you are. But the reality is that a warehouse is actually a relay race. And siloed automation creates bottlenecks. There are multiple dependent processes, and the baton passes, so to speak, have a habit of being the stumbling blocks to efficiency. Bottlenecks tend to occur at the handoff points where there is little intelligent process control or visibility, and the upstream processes can often overwhelm downstream capacity without any visibility to the fact that that is even taking place. Unfortunately, you tend to not even know there's a problem until it's far too late. But people can't be everywhere at once. There's no way that they can manually resort work fast enough to prevent these kinds of issues, even if they see them coming, which is why it's been so difficult to maintain continuous flow systems. The concept of planning work in batches or waves, so to speak, has really been a necessity because the people have been the ones doing the planning. But in order to get to a next level of efficiency where work is continuously flowing, and also where work is continuously being controlled to prevent these bottlenecks in advance, intelligent software is needed to process all of that data about what's happening in your warehouse in real time and adjust the work assignments proactively to prevent these bottlenecks. Engineering and building the fastest possible pathway is often a long and very costly process. Generally, once built, that path isn't very flexible, meaning that if your business changes, you once again have a long and costly redesign and rebuild process. So fixed path automation ends up becoming a pretty expensive risk. Ultimately, the fastest and most efficient solution is also not universal. It's often situational. So in this particular image, the tractor obviously hauls substantially more product, but it moves a lot slower. The car behind it needs to get to where it's going much sooner than the tractor, but it's now stuck in single file line. Having a single path that can be bottlenecked by poor planning or improper prioritization ends up causing downstream bottlenecks and potentially gridlock with no alternative for a release valve, so to speak, where those orders that are higher priority can move around or get past the situation that is either caused by either a slower order or larger order, or truly an exception scenario where the machine has failed in some way and now there is a gridlock situation. Having multiple paths to choose from, especially when conditions on the floor make one path a far better choice than another, prevents bottlenecks and increases throughput. For example, when software-driven robots can move product anywhere they need to go and to anywhere they need to go, there is no need to define one single path. If one robot has an exception, then you can easily assign another robot to go and pick up that slack. It allows for intelligent path assignment and intelligent recovery from a bottleneck situation or from an exception situation. Again, people don't have enough information to make these decisions about which path to take in real time. And so as a result, this has not been an option traditionally to human-based systems of planning. However, with intelligent software, it's possible to maximize the value of dynamic pathing by automatically adjusting work assignments and instructions to take the best path for the situation. The end result is a reduction in bottlenecks and a higher probability of continuous flow of work because you have more options to choose from. Again, not every path is going to be the best option for every single situation. And the whole point of the software is that it should be able to help make the right decision without having a substantial amount of human assistance to make that decision. Which ultimately brings us to people themselves. So people, not machines, are the key to flexibility in warehouse automation. The key is because people are a central part of software-based automation. They're the physical link between siloed machine automation systems. Machine automation systems generally don't understand or don't have visibility to everything that's happening around them. Usually they're focused on one specific task. There are transition points What I mentioned earlier is the baton handoffs in that relay race. Those transition points are the places where people generally have to come in and facilitate the process either to the next manual step where the people do the work, or to the next automated step where another machine takes over. However, during those transition points, the people have a challenge in that they don't have enough information oftentimes to make the right decision quickly. And so you get situations where either one, they don't make the right decision and you have accuracy problems, or two, they do make the right decision, but they make it slowly and you have efficiency problems. However, people are faster and better than robots for everything but long distance movement and carrying capacity. The key is that they just need to have the right information and the right instructions so they can make those decisions quickly and accurately. Intelligent software empowers frontline workers with all of the instruction and information they need to make the right decision. And more importantly, it connects them with robots and other machines and artificial intelligence that increases their capacity and their travel speed. Working alone, people have a lower capacity, but working together with connected automation solutions, people have a much greater capacity as well with the assistance of collaborative automation. So lastly, we'll get to work processing or work planning. Software-based automation should create a river, not waves. Waves, by their very definition, have a peak and a trough. There's a hurry up, then there's a slow down. Then there's a hurry up, and then there's a slow down. And unfortunately, no matter how tightly we time those waves, no matter how much we try and intelligently select what orders should go in the next batch, for example, it's often very difficult to perfect it. And certainly, almost no one I've ever spoken to says they love their planning process for their work. In fact, many companies I talk to are asking, how can I make this automatic? And that's the whole point of software-based automation. Software-based automation is about increasing the effective utilization of every aspect of your warehouse, creating a river. Now, that might be a rushing river, a fast-paced current, and that's obviously a good thing. The faster, the better, as long as it's not waves. If you truly have that up and that down, then you have ineffective utilization. And the end result of ineffective utilization is that you have to either one, overstaff, or two, overdesign. In either case, you're spending more money than you should be. Ideally, if you have a consistent flow of work and you have enough paths and options that can be dynamically selected by the solution, by the software, then you have the ability to adjust the size and staffing and utilization of your various assets based on the flow of work that is expected for a given period of time and based on the actual work that's in the system and in your facility at any given point in time. But ultimately, achieving that consistent flow requires software because, again, this is more information, more data that a human can process without additional assistance. And so all of these factors come together to create what is ultimately a much more efficient outcome. However, it's entirely predicated on the ability of software to connect all the dots. Automation systems, fixed automation systems, have powerful capabilities to move vast amounts of product very quickly. However, they also have the downside of potentially becoming bottlenecks if something goes wrong, or if they're overloaded by the demand of the order profile for that day. The ability to have an AI automated next best decision work assignment process based on real-time conditions allows us to take a step towards creating that river. And instead of having the up and down of waves, instead we have a continuous flow of work that is uninterrupted, hopefully, throughout the entire course of a given day. More importantly, even if it is interrupted, which we know exceptions will occur. That is pretty much the norm. So especially if the last year has taught us anything, exceptions will occur, but how the system responds to those exceptions, how much effort and how much difficulty it takes to overcome those exceptions is where intelligent software can make a substantial difference by having visibility to the current process or the current state of processes that are taking place in the facility, and then making decisions based on that information, those real-time conditions, to determine what's the next best thing to go out. Also, dynamically selecting the best and lowest cost flexible path, again, based on current conditions. If you have multiple options, and different options have different costs, and quite honestly, the cost of each option may differ based on the conditions in the warehouse. How many people do you have working in a given area? How is this piece of equipment already at its maximum capacity, or is it shut down? Does it need to be started up just to use this path? All of those considerations factor into whether or not it makes sense to use this path. Obviously, maximizing the effective capacity of an expensive piece of fixed automation is a critical factor in software-based decisions. The software should be doing everything it can to make the best utilization it can and achieve the best ROI possible out of that expensive piece of fixed automation. But if it doesn't make sense to use that piece of automation for a given order or a given task, then picking a different path that allows for that order to follow, and get around the tractor trailer from the previous slide, and instead get to its shipping window within a service level agreement for an e-commerce order, for example. That path and that decision needs to be made by the software without a person having to interact and request that change to be made. When we're talking about people, ultimately we're talking about technology augmented people, and I think that's that's a huge factor here. Is the system are the people serving the system, or is the system serving the people? And in our model, the system's job is to ensure that the frontline workforce has all the information they need, all of the process control that they need to do everything they can do as correctly as possible and as efficiently as possible. And then AI automated flow control that brings all of it together to help have visibility to processes, visibility to bottlenecks, and then proactively adjust decisions to prevent them. So in summary, we need to start engineering automation hardware with a focus on cost efficiency and not just speed. We need to think about maximizing utilization, not just speed, because utilization is actually the key to efficiency and efficient throughput. We need to prevent bottlenecks because they are a major killer in utilization. If the capacity of the system is truly stopped because the system is stopped, then no efficiency can occur, no throughput can occur, and ultimately the exception processing becomes a very expensive event, usually an event that we have to throw labor at. Having multiple inexpensive paths is the key to preventing all of those bottlenecks, and then enabling people with technology and connecting them to everything around them to help them move more and faster together than they could ever do alone without the mechanical assistance. That's where the software part of automation can bring everything together to connect siloed machines and processes and people and drive a level of efficiency that has never been possible before with just large fixed automation machines. Thank you for watching, and I look forward to discussing your questions.